Hey, boys and girls, this is Mr. Bell. Today we're going to be talking about finding the area of complex shapes. All right. What I want you to know by the end of this video is how to find the area of a complex shape using what you already know about finding area of regular shapes like rectangles, triangles, rhombus, and parallelograms. All right. You're going to combine those shapes to make complex shapes and then find the area of those complex shapes. All right, so I'm going to give you two examples, and then I'm going to give you a real-world problem that you may just use to have to find some sort of area. All right, so here we go. The first example, I have a shape that looks like that. Okay, now the shape is, let's say we'll call that centimeters. 5 centimeters tall, 4 centimeters wide. And this little distance from here is 3 centimeters. Now that's the distance from here to here. And we have this total distance down here of 7 centimeters. All right, so this little part right here is giving me a hard time. I can't figure out the area of this shape as it sits. Okay, so what I have to do is I have to divide this shape into smaller recognizable shapes that I can easily find the area of. Okay, so the first thing that I see is I see a rectangle and I see a triangle, and I can find the area of a rectangle and a triangle. So I divide this shape into smaller shapes. Okay, now so I have to use the formula for both of these shapes. So the area of a rectangle formula is area equals base times height. The area for a triangle is area equals 1/2 base times height, or as we were talking in class, area equals base times height divided by 2. You could use either one of those, does not matter. You're going to get the same result. Okay, let's start with the rectangle. That seems to be the easiest thing. Rectangles usually ask for base and height. Now, if I use the base here, the base that I'm looking at is longer than the size of the rectangle. So I can't use that 7 for the base of this rectangle. I have to use something that represents the width and height of this rectangle. So 4 covers the entire width of the rectangle. So that's the first number I want to use. The second number, I'm going to call this the base. The second number needs to be the height. Well, I got two numbers here that could possibly represent the height. There's the 3, but the 3 only goes from here to here, so it doesn't go the full length of the rectangle. But here, I got 5 does. So that is my second number. So now all I got to do is multiply 4 times 5. The area of just the rectangle equals 20 centimeters squared. So I'm not done yet. 20 centimeters squared is the rectangle. Now I need to find this little guy right there, that little triangle. So what I need to do is figure out the base of the triangle and the height. I'm going to kind of draw that right there. The height of the triangle. All right, so I need to take what I already know about the rest of the shape, and I can figure out these dimensions. So if I know from here to here is 7 inches, and since we've already figured out the area of this rectangle, I said this width here was 4. That means this width here is also 4. So I can subtract 4 from 7, because this total length is 7, and just this part of it's 4. So if I subtract 4 from 7, I'll get that length right there, which is, and I'm just going to draw an arrow, 3 centimeters. Okay, so that's the base of the triangle. Now I need to figure out the height. And I can do the exact same thing here. I know from here to here is 5 centimeters. That means from the bottom of this shape all the way to the top is also 5 centimeters. But it doesn't tell me how long this line is. But I do know that this line from here to here is 3. So if this is 3 centimeters, what do I have to add to the 3 to get to 5? Well, the answer is 2. So this dotted line, I'm drawing it real small, is 2 centimeters. So that means my area equals, we'll say 2 times, what did we say, 3 divided by 2. 2 times 3 is 6, divided by 2, area equals 3 centimeters squared. So just that triangle is 3 centimeters square. So now I have to combine the area of the small triangle and the area of the big rectangle, and that'll give me the total area of the shape. So I take the area of the rectangle, which is 20 centimeters squared, and I add that to the area of the triangle, which is 3 centimeters squared. That's easy enough. That's 23 centimeters squared, and that's the area of our shape. Okay, so here is our second shape. What we need to figure out is the area of just the shaded region, just the shaded region. So I can look at my shape, at both of these shapes, and just say, okay, I have a square here, which is 3 centimeters by 3 centimeters, and then I have this square in the middle, which is 2 centimeters by 2 centimeters. Now, what I need to figure out is the area of the shaded area. So if I just multiply once again, for a square, area equals base times height. If I just multiply the base and the height, that's going to give me the area of this entire square. But I want the area of that entire square minus this smaller square here. Okay? So let's go ahead and figure out the area of the bigger square. It's area equals 3 times 3. So my area of the big square is 9 centimeters squared. But I'm going to subtract that. Well, I'm going to subtract the area of the smaller square from it. So area equals base times height. My dimensions are area equals 2 times 2. That tells me the area of that smaller square is 4 centimeters squared. So now I just have to subtract the area of the big square, the area of the smaller square from the area of the big square. So I say 9 minus 4 equals 5. So that means the area of just the shaded region is 5 centimeters square. Okay, so in this particular shape, I had two squares. I had to subtract one of them from the other one in order to find the distance around it, sort of. All right? Okay, this is our last example, and this is a real-world example, meaning this is the type of problem that someone might encounter in their regular, everyday life, and they need to solve it. Okay, so here's a real-world problem. The problem says, how many square yards of grass are going to be needed at an apartment complex that's just being built? So, you're given this picture right here. Okay, and you notice that the apartment complex consists of an apartment building, what looks to be a walkway, a parking lot, and a pool. Okay, so none of those areas need grass. But all the remaining areas, the green areas, are going to require grass. So we need to figure out how much grass that we're going to need, how many square yards of grass that we need. So there's a lot going on in this problem, and this will take a little bit of time to solve. Okay, so writing down parts of this problem are essential. So this is how it's going to work. I'm going to find the total area of the apartment complex, and then I'm going to subtract the area of the parking lot, the area of the pool, the area of the apartment building, and the area of the walkway down at the bottom. And then once I subtract all of that, what's left is the area for the grass. So let's get started. All right. First thing I want to do is the apartment complex. All right. So area equals, for rectangles, it's base times height, and that's all these shapes are rectangles. So I have 110 times 100. Area equals, and I'm just going to multiply these things together. And I know that when I'm multiplying by powers of 10, I just add the number of zeros that I'm multiplying by to the end. So the total square yardage, oops, that's a 2. Is 100, not 110, but 11,000. 11,000 square yards. All right, so that's going to be my big number. That's what I'm subtracting everything from. So let's go to the pool next. All right, the pool is, looks like 11 yards, 27 yards by 11 yards. So I multiply these two numbers together. 27 times 11 27, 0, 27. That's 7, that's 9, that's 2. So that's 200. Oops, let's erase that. $297 square yards. All right. All right, yard squared. Now I want to go to the parking lot. All right, what is the parking lot's dimensions? The parking lot is 50 by 30. So once again, it's a rectangle, so 50 by 30. Multiplying by powers of 10, except this one has a 5 and a 3 in the front. I know my answer is going to have 2 zeros added on to whatever 3 times 5 is. 3 times 5 is 15, and then 2 zeros. So 1,500 yards squared. All right, next is the apartment building. That's the complex. I don't want to get you all confused. This is the whole complex. All right, this is the apartment building. All right, the apartment building is 85 by 40. 85 by 40. One thing you have to keep in mind is make sure all your dimensions are in the same unit. Okay, we did have a problem before where I mixed it up and I said, "Ooh, you gotta find the area of the shape," but you got one is in centimeters, one is in millimeters, or something like that. So anyway, everything is in yards. We've already checked. So 85 times 40. I'm just going to do that math over here. I'm going to say 40, 85. Drop that 0 down. 4 times 5 is 20. 32, 34. So 3,400 or 3,400 yards squared. All right, and the last shape is that little walkway. All right, we're going to say walkway is 10 yards by 10 yards. So that one's easy enough. That's 100 yards squared. All right, so far I hadn't had to do a whole lot of math on paper. I was able to do some of it in my head, but writing this down does not hurt. Okay, so I found out all the parts, right? There's the parking lot, there's the pool, there's the apartment building, and the walkway. Yep, and I got it all. Pool, parking lot, apartment building, walkway. So now I want to subtract them all. Okay, let's just start here. So I'm going to start with 11,000. 11,000. And let's subtract the 297 from it. 297. Have to borrow from this. That becomes a 0. That's a 9. That's a 9. That's a 10. 7 from 10 is 3. 9 from 9 is 0. 2 from 9 is 7. I bring that 0 down, and I got that 1. Okay, so that is how much the apartment complex is less the pool. All right, so this is the apartment complex without the pool. Let's go ahead and subtract the 1,500 for the parking lot. 1,500. 0 from 3 is 3, 0 from 0, 5 from 7, and then 1 from 10 is 9. So now I'm down to 9,200 yards. I've taken care of the pool, I've taken care of the parking lot. Next is the apartment building. All right, I'm going to kind of move this up here so y'all can see it. All right, so I got 9,203. If you ever do something like this, make sure you copy your numbers right. I'm going to subtract the 1,500 for the apartment complex. I got 3, 0. I can't subtract 5 from 2, so I got to borrow. 5 from 12 is 7, and then 1 from 8 is also 7. So now I've taken care of the apartment building. The last thing I have is the walkway, and that's easy. That's 100 square yards. I subtract, I get a 3, 0, 6, 7. And I think that covers me. Got the pool, got the parking lot, got the apartment building, got the walkway. So the total amount of grass that this maintenance guy would need, or the apartment complex owners would need, is, what is it? 7,603 yards squared. And that's my final answer. Okay, you might see a problem like this on a test, and it may ask you if grass is, I don't know, $8 a square yard, how much money will it cost to, put grass in the complex? So keep in mind that there may be more steps to a problem like this. But for our purposes here, for what we just did, 7,603 square yards is our answer.